root-locus technique. Root-locus is a powerful technique in the analysis and design of the control system. Root-locus is basically a graphical method for analyzing and designing of the control systems. What is this root-locus? Root-locus is the locus of the roots of the characteristic equation or poles of the closed loop transfer function when the open loop gain k is varying from 0 to infinity. That means you can look at the definition again. So, root locus is the locus of the characteristic equation, roots of the characteristic equation. So, but how the locus will get? Locus is a graphical method, okay, it is a graph. So, locus of the roots of the characteristic equation when open loop gain k is varying from 0 to infinity. So, in Routh-Harwich criteria, we know that we can find out the range of k values for system stability. For example, if k is in between 0 and 6, system is stable, and greater than 6, system is unstable, like we have a conditionally stable nature. But in this case, not only the range of k, at each value of k, what would be the roots of the characteristic equation or location of poles of my closed loop system. So, this will give us the complete picture of your system poles, which means your closed loop poles. That is, when k is 0, where are the poles? When k is 2, where are the poles? When k is infinity, where are the poles? So, the entire information is available in root locus, therefore, it is very powerful technique in control system design. This root locus was developed by W.R. Evans, and it is very powerful technique. Now, so let us take one example and see what is the origin of the root locus. So, I am taking one example here, it is a closed loop system. And in this closed loop system, I have g of s. G of s is I am taking k by s into s plus 2, and you have unity feedback, h is equal to 1. Then I want to know the location of closed loop system, poles of the closed loop system when the parameter k is varying from 0 to infinity, the complete variation, right? The k is when 0 to infinity, what are the locations of those poles? I need to find. That is what the root locus is, or the roots of the characteristic equation of the system. We know that the roots of the characteristic equation is nothing but the poles of my closed loop system. So, stability depends on location of closed loop poles or the location of roots of the characteristic equation. So, root locus means we are using a terminology root. The root is the roots of the characteristic equation, which means my closed loop poles. Ultimately, we are going to look at the complete picture of my closed loop pole locations for all the variations of k from 0 to infinity. So, let us do that way for this particular problem. So, let us write the characteristic equation 1 plus gh is equal to 0. So, that we will be getting s square plus s 2s plus k is equal to 0. It is a simple second order equation. Then you can write two roots, that is s1 is equal to minus 1 plus under root 1 minus k, and the other root is minus 1 minus under root 1 minus k. These two are the roots of this particular equation. But we do not have direct value here, instead we have a parameter k. So, it is very clear from these two s1 s2, when k is varying, s1 value, s2 value will vary. What are these s1 s2? These are the roots of this characteristic equation, or as I said, the s1 s2 are my closed loop poles. Now, let us formulate a table and see how the variations of s1 s2 for different values of k. First, we will take k is equal to 0. When you substitute k is equal to 0, then it is very clear that s1 is going to be 0 and s2 value is minus 2. Then again you substitute, just increase the k value. Let us say k is equal to 1. When you substitute, you will be getting minus 1 and minus 1. So, formulas are available, simple substitution. Then when k is 2, you will be getting it as minus 1 plus j1 and minus 1 minus j1 when k is 2. And increase slightly when k is 10. then you will be getting as minus 1 plus j3 minus 1 minus j3. So when there are complex, we have always they are in pair. Then for example, if you substitute 100, you will be getting minus 1 plus j10 minus 1 minus j10. And when you substitute the large value, for example, if you substitute 10,000, we will see what we will get. Minus 1 real part is same plus j100 minus 1 minus j100. Even if you substitute input, you can imagine that it will be minus 1 plus j infinity minus 1 minus j infinity. So these are the k values. I am varying the k value from 0 to infinity. I am taking a few distinct values. In fact, you can take 0, 0.001, 0.002 and so on. As many number of k values you want, you can take it. And corresponding S1, S2 we can find out. So once this table is available, locate those points on S plane. So we know that the S plane is nothing but we have the real axis and the imaginary axis, and this side is called left of the S plane, that is from 0 to minus infinity negative real axis, 0 to plus infinity positive real axis. This is positive imaginary and positive negative imaginary. So it's a complex plane in a rectangular coordinates, real and imaginary. When you locate this, so you can look at this S plane. When k is 0, I am going to locate my first pole is at origin and second pole is at minus 2. This is minus 2, this is origin, two poles are here when k value is 0. So I am trying to explain you how this root locus will origin, how these poles will be moving when k is varying. Now in the second case, k is 1. When k is 1, what are the values? You have minus 1, which means, so earlier k is 0, one pole is at origin. As you increase the k value from 0 to infinity, so one way you can understood that we are giving energy to the pole. Then what that pole, the pole will try to move, and where it is moving from 0 to minus 1. Similarly, the other pole is also moving, the energy is given to the system in terms of k. So that pole moves from minus 2 to minus 1. Therefore, both poles are at minus 1 when k is equal to 1. So if you increase the k value, k is 2, I said it is minus 1 plus j1. That means these two poles are splitted. One is going in a complex and it is settled at minus 1 plus j1. The other is going downwards, minus 1 plus minus j1. So one pole is here, another pole is here when k is 2. Even if you increase k at 10, 100, 10,000, so the real part is same, only imaginary part is varying. Therefore, you will get a straight line from minus 1 to plus infinity with a real part minus 1, and another pole will move towards the downward direction in the negative imaginary, that is minus 1 minus j infinity. So this is what is called root locus. What is the definition of root locus? Root locus is the locus of roots of the characteristic equation. You can look at the locus. What is that locus? You have two roots, therefore two root locus branches you will be having. One root locus branch starting at 0 and coming to minus 1. For example, it is going to positive infinity in this direction. So another is here minus 2 and it has gone to this minus 1, it is going to your negative infinity. So these are the loci, we can call it as the locus of two branches is the loci of the system. So when these two poles are here, the minus 1, this point is usually called break away point, because one pole is at origin, another pole is at minus 2, both are coming to minus 1, they are meeting here. After that, they are entering into the complex plane. So this point is called breakaway point, and we will see all the terminology when we are discussing the root locus rules. So this is the root locus for variation of k from 0 to infinity, how my two roots are varying.